What I'm going to do is I'm going to break up the discussion on the stability of these two equilibrium points in two parts. So first we'll discuss the stability for this equilibrium state A1, and as I said earlier, we're going to discuss this in two parts. So here you can see above the x-axis, x dot is going to be positive, right? Because x dot is what you have on the vertical axis. So anywhere above the x-axis, x dot is positive, whereas below the x-axis, x dot is negative. That's one piece of information that we have. Now let's suppose we are at a point like A. Okay. Now what is the characteristic of A? First of all, at A, x dot is positive, which is to say that, now this is at A, okay. So at A, x dot is positive, or dx by dt is positive, which is to say that as time passes, as t increases, x also increases, okay. So if x increases, then let's see what is going to happen. Now at A, we also have that dx dot by dx, the slope of the curve, which is given by dx dot by dx, that is negative. Now we are asking what happens as x increases. So because as time passes, x is increasing. So as x increases, clearly at A, x dot has to go down. Okay, because this dx dot by dx is negative. So if x increases and x dot has to go down, then from A you're going to take a path like this. You're going to move back to your equilibrium state. You're not going to move away because x dot has to fall as x increases. So the idea here is that if there is a perturbation, if you move away from the equilibrium state to a point like A, you're going to come back to A. Now let's see what happens at a point like B. Now at B, what is happening is x dot is negative, which is to say as time passes, x is going to fall. So as time passes, as t increases, x falls. Okay. So also because dx dot by dx is negative, that is to say x dot has to go up, because if x is falling and dx dot by dx has a negative sign, so if x is falling, x dot has to go up. So if you're at a point like B and x is falling, then you will be on this path. X dot has to go up. So again you can see you're moving back to the equilibrium state. So the point here is that this equilibrium state A1 has to be a stable equilibrium state.